Muller, staff scientist, program manager, Marine Laboratories, Coral Disease and Health Program.
And for someone who doesn't know anything about ocean acidification, why don't we start with tell us what's happening with the carbon dioxide in the atmosphere.
Well, as the atmospheric carbon dioxide accumulates, it actually gets absorbed into the ocean. When that happens, a series of chemical reactions take place that ultimately lowers the pH, changing the chemistry of the water that we know today to be something very different.
And lowering the pH means making it more acidic. How does that affect different types of organisms?
Right, so more acidic waters can do things like reduce the ability of calcifying organisms to build that calcium carbonate skeleton. So it actually makes it more difficult for them to grow. So things like corals, shellfish, crustaceans might have reduced growth rates, or eventually, if the pH gets too low, may actually have dissolving skeletons over time.
How might that affect Florida?
Well, Florida really relies on their coral reefs for several different economic reasons, from fishing to shoreline protection. So a dissolving coral reef can actually considerably hurt the economy of our state and reduce the ability of it to be buffered from storms as they go through.
So you were just talking about just reducing the pH, but that's not happening by itself. It's also happening with warmer oceans. How do you think that global warming and ocean acidification might work together for these organisms?
Right, so the oceans are getting warmer as well as the pH declining, and when that happens, there may be some synergistic effects that we see. Already warm water temperatures are causing coral bleaching events worldwide. Right now there's a coral bleaching event occurring in the Florida Keys. That means that the corals there are very stressed because the water temperatures are too high. If you add in a decreasing pH, that may increase their susceptibility to things like coral bleaching as well as infectious diseases. When they're stressed from an unfavorable environment, they're more likely to get sick and they're more likely to die from these disease outbreaks in the future. At least that's what we speculate will happen.
Since you mentioned the coral bleaching event in the Keys, I haven't heard a lot about it. What can you tell us? Where is it happening? How serious is it? And why is it happening?
So at least I don't know the spatial variation within it, but the water temperatures in the lower Keys have reached 32, and prior to the remnants of Erica moving through had sustained those temperatures for weeks. What that is doing is it's making the corals extremely white because they're losing their symbiotic algae within their tissue that gives them the color. They're extremely stressed living in this environment, and if it continues to occur and water temperatures don't drop significantly in the near future, we'll also have a lot of mortality associated with this event.
How has this event compared to the serious one last year and the bad ones in the past?
It's already very comparative to what happened last year. Almost all species are now being seen with some type of bleaching signs associated with them. We're seeing some mortality already of some of the more susceptible species, and so this could gear up to be a very impactful, potentially catastrophic year if water temperatures don't start to decline very soon.
And I want to change gears just for a second, if you have another second. And you mentioned something during your presentation about the restoration work you're doing with Flora Cervicornis, and that you're looking at genotypes that might have a better ability to adapt maybe for those three things. I think you were talking about disease, acidification, and bleaching.
Yeah.
That's really interesting. I'd like to have you talk about that.
So we're already in the process of restoring the coral reefs. With one particular species, we've really ramped up production, and that's the stag. And we have thousands and thousands of these individuals that we're taking care of within our nursery. Of those thousands of individuals, we have about 50 or so different genotypes. That means we have a lot of identical twins that we are propagating and putting out onto the reef in the hopes of restoring that reef. What I'm trying to do is to figure out of those genotypes that we are putting out there, which ones are going to be the ones to survive 100 years from now, which ones have the ability to resist high water temperature, which ones can be resilient to ocean acidification, which ones are more robust against disease infections, because those are going to be real winners years, 100 years from now, as our environment keeps changing. Once we understand a little bit more about the ability of these genotypes to resist the three major stressors affecting reefs today, we can conduct more informed restoration plans. So we can put these corals that are resistant to ocean acidification in areas that aren't going to be buffered by low pH in the future. We can put corals that are going to be resilient to disease in areas that may be more influenced by runoff associated with the Florida Bay or with sewage, that could be spilling out in the Florida Keys. So we can increase the probability of having a successful restoration project now, with the idea of putting those individuals out there that are going to survive a few years from now.
Have you gotten enough results to know whether there are genotypes that are better at any of those three?
I'm just starting some of the preliminary tests this summer, actually, and we're seeing, at least with disease susceptibility, there are certain genotypes that, as of now, are robust against the diseases that we're seeing out there right now. So that's a good sign. In the future, we'll be doing challenge experiments to increase temperatures, decrease pH, and see if that robustness against disease continues even when the environment changes. So within a year or two from now, I'll be able to tell you a little bit more about what's going on with that.
And I just want to make sure that we get a definition of a genotype that people can understand. Genotype is kind of like how genetically different organisms are from each other.
Right, like you and I would be different genotypes of each other, but if you had an identical twin, you would be the same genotype. And so we have a lot of identical twins out there because corals propagate through fragmentation. So we can use that to our advantage and propagate those individuals that are resilient to the three major stressors. Thank you.